Good evening, Kyiv. Hello. Okay. Oh, I see it's my talk here. My name is Aleksander Dąbrowski, and I will tell you 7 stories about popular performance scenes people commit developing Rails applications. And that's the first story. The year was 2016. And after 2 years of really heavy work, we were launching our new service. And we didn't have a clue how many people will use our site. We have no idea. We did some marketing, we collected some emails, prepared newsletter, but we had no idea. And I have to confess that we didn't have a clue how many instances we need to properly serve all load. We had 2 unknowns. So we increased number of instances and hoped for the best. We crossed our fingers, and it worked. We didn't crash. We launched. But to this day, I don't know how many instances we needed back then, and how long did it take to serve each request. We were on a time we were hosting on Shelly Cloud, which was Heroku-like platform, and just after the launch, we received message from them that they are closing their business, they're shutting down, and we had to move somewhere else. And we were really tight on a budget, and every penny counted. So we had to look at every penny from every side. And we decided to use dedicated servers instead of some cloud providers. We thought that was cheaper. So we booked 2 powerful servers, negotiated the deal again, because we were tight on the budget, and signed the lease for 1 year, migrated our site to these dedicated servers, and we made the switch. We knew how many clients we needed to serve because we already launched it, but still, we didn't know how long does it take to serve 1 client. We didn't know our responses times. So we had 1 known value and 1 unknown. And we moved to dedicated machines, and then we looked at our servers. Each of our servers had like 12 cores, and how much were we using? 1. Did I mention we were tight on a budget? The lesson here is that measuring performance is the single most important thing you can do. You need to set up some monitoring. It might be New Relic, it might be AppSignal, Skylight, Datadog, whatever. You can produce some logs, aggregate them with cron job, grab them, whatever. You need to know basics about your system. Not measuring things on production is a sin, and it's a cardinal one. Only then you can see if your site is fast, only if you are measuring it. You may not know number of clients. That's okay, that changes. But you should know speed of your application. And by speed, you should monitor few things. Of course, you should monitor mean time of your requests, probably median of your request. And you should monitor 95th percentile. What is it? It's time to serve 95% of your requests. And this number, 95, depends on situation. Sometimes it may be 90%, sometimes it needs to be 99. Imagine, for example, you have single-page application, and it takes 20 requests to properly load all your page. And if only one every 20 requests is slow, your app may be perceived slow. So that's why it's important to keep track of 95th percentile. And mean can be misleading for many reasons. Bill Gates walks into a bar and suddenly the mean net worth of the crowd jumps to 1 billion. On our site, we had a live search. This site, which is Koleo, is the fastest growing train ticket application in Poland. But the thing you do when you visit our site, you type from and to, you choose the date, and you get a timetable of trains. So we of course needed live search. And in Poland, we have more than 2,000 stations. So after few letters, you would see 5 prompted stations. And it's really important because that's the first element which is used by user. So that's the first impression. It needs to be fast. Nobody wants to type character and then wait even 2 seconds. Even 1 second in live search is too slow. So in order to make it fast, we preloaded all these stations and did front-end live search, which was like obvious choice. That way, we didn't lose time to long round trip between browser and the server. And also, we didn't have to wait for a backend to find matching stations. We were protected from browser latency, especially on mobile, which in transport app, the mobile is a king. And all of this was done on frontend and worked quite fast. But there was one small problem. In order to make this front-end live search work, we had to preload all stations. And we had more than 2,000 stations. And also the stations had some fields like geographical coordinates, translations, etc. So we had to request for about 2,000 stations and populate stations objects. So it all takes time. So first of all, backend had to query database, serialize all these, create 2,000 Ruby objects, serialize these objects, return JSON, which was like 200 or 300 kilobytes in weight, transfer it through the network, and then JavaScript, we were using Ember, had to create 2,000 JavaScript objects. And it was necessary to start using our page. So we were blocked. User couldn't do anything before all this was done. And it took about 1 second to download and mostly on a JavaScript part, parse and create these objects. And it took even more time on mobile. So what we did? We created a branch called backend live search, move all live search code to backend. That was easy part. And because also we were relying on preloaded stations. We had to change a lot of in frontend to not rely on preloaded stations. And we deployed this branch on production, looked at analytics after 2 or 3 days. We were again relying on backend. Also, search results was slower because we had to load station names for every search query. But it speed up loading of our site by 20%. And it, of course, decreased bounce rate, and was great change despite increasing a load by little. And by little, I mean 3%. We also measured this. And here we come to the second scene called optimization without measurement. It's like cooking without tasting. Your food can look tasty. You may think it is tasty, but in reality, it may taste not so good. And you probably know the next quote. The full sentence says, "The real problem is that programmers have spent far too much time worrying about efficiency in the wrong places and at the wrong times. Premature optimization is the root of all evil, or at least most of it, in programming." And the lesson here is that optimization isn't root of all evil. Optimization without measurement is. You have to apply scientific method to optimization, so you have to monitor your responses before the change, introduce the change, and observe what happens. And sometimes the best solution is not the most obvious one. One day, we hired this very smart guy, and that was his job title, growth hacker. You know what growth hacker do? Yes, excellent, yes. Growth hacker is a person who wants to generate growth, and it can be done in one of 3 ways: by search engine optimization, paid campaign, or shady or illegal activities. And we, of course, focused on the first 2. And in order to run Facebook ads, we wanted to have a paid campaign in Facebook. So we added Facebook pixel script. Switch. That's the slide with code, so you should see it. Okay, that's the one. That's Facebook pixel code. It's an easy-to-add script that allows you and Facebook to spy on users. It works simply like Google Analytics, but for Facebook. And we created some ads, tested it for a while, and we were losing money. And they performed poorly. So we disabled them. We get rid of all these ads, tried a few other things, and after a few months, our growth hacker left. And 1 year later, I was using Google Lighthouse to test front-end speed of our site. And I noticed that we still have this Google Pixel code on a site. It was one of the 50 requests we had, and we totally didn't need it. So we deleted it, and after a few days, looked at analytics. And we noticed 50% increase in speed, just by deleting this one of 50 requests. So that was like 2% of request. That was one request, and we didn't need it. We, of course, reduced other things which help our business, like reduced bounce rate and loading of faster site loading, more users. And we were happy not to give more data to Mark Zuckerberg and also be cool with GDPR. And that's how we come to the third sin, which is doing too much. And let it if you want to lose weight, you have to eat less, for example. You can think that you should fasten, or eat fiber, or don't eat fiber. Drink black tea, or don't drink black tea. But simply, if you want to lose weight, you have to eat less. So you have provide less calories than you spend. And with all optimization, there is the same thing. It also applies to agile development. If you want to deliver code in some fixed time with fixed team, you have to limit the scope. And if you want faster code, this code has to do less. And you can do it on two levels. One of them is by the limiting features, which probably it's the hardest part because you have to negotiate with your client or with your team, product owner. Features and scope, you simply can do less. Maybe you don't need to log everything. Maybe you don't need to calculate everything. Maybe you can simply have faster features. And the second one is on code level, which for most developers is easier. You just have to find bottlenecks. You have to find code which is executed many times and find a way to replace this code with faster alternatives. And very special word in computer science for this, it's called, again, it's not working. Terrible. Not working. No, it's a problem with Wi-Fi. No, escape. Oh, okay. It's algorithms, of course. So be smart, be clever, and reason about your code. That's the shortest story here, but it's an important one. I said you should do less, but your application has to do something. And there is a limit how much computation actually we can skip. Your application has to do something. And it's possible that we are doing some things over and over again. And maybe it's possible to retrieve data, for example, and store it in memory. And here comes the cache. With caching of web applications, most people tend to wait to implement it until they encounter performance problems. It may be too late. It's like forgotten feature. People don't think about cache when they're developing their application. They think about cache when their site is slow. And it may be a tricky one because in Rails there are many levels of cache. There are multiple layers, and you should use the right one for your project. Because, for example, if you have a lot of small requests to the cache, and your cache is far, far away, it may be faster not to use it at all. And otherwise, sometimes you need shared cache for everything what happened in your application. So using the wrong cache may slow you down. So don't neglect the cache, use the right one for a job. And this talk has to be about active record, at least a little. Because the truth about active record is this. It's great and it's terrible on the same time. It's probably one of the greatest and the most terrible parts of Rails. It can be a source of great misery. But it's a tool, so like every tool, you have to handle it properly. And when we talk about speed of application, active record is probably one of the places where you should start. And probably it's one of the places where you spend much too much time. So you have to understand active record and know how it works. This is nothing new. That's some beginner stuff. So you write active record methods in Ruby, then active records performs some SQL queries, and it returns results wrapped in Ruby objects. It all takes time. And it all takes time, especially on a Ruby part, because active record is not database, it's a Ruby wrapper. So every time you execute active record, you create Ruby objects and execute some Ruby code. And sometimes tons of it. You know the funny thing about active record is? It's a little differences. So we have 2 lines of code here, and they look almost the same. But on the second one, you have author object. And not only it adds extra query to database, but also it creates additional Ruby object, which takes some time, takes some memory, and sometimes isn't needed at all. And sometimes it gets worse. You know the name of this problem. No, it's not n+1. Of course, it looks like n+1. But in this code, you can try to add author here, includes. So this way you solve n+1 problem. But in this case, we shouldn't include author at all. Problem is here. You should use author ID instead author.id. Black?
Yes, use black.
You have seen my presentation already. That's the first time I'm saying it. Cool, you have time machine. So we get rid of author object, and if only we need author ID, we should use plug. So it saves a lot of work both on Ruby and on DB side. And these are small things, of course, and most of us know about it, but we may not remember about it every time we are writing up. We don't need to load author object, and we don't need to create book objects. We just need author ID. And instead of creating whole arrays of Ruby objects, loading all these fields, we can just return strings. It's so much faster. And let's put it straight, active record objects are heavy. So it's so easy to work on autopilot, creating tons of unnecessary objects. But sometimes you just need 1 or 2 fields. It's very easy just to load whole objects. Forget, for example, about select method. I very rarely see this method in code. Everybody just load whole object. And this method allows you to specify which fields you need. There is also another pattern, which I also see too much. So what we have here, we ask database for books. Database has to retrieve rows, pass them to Ruby. In Ruby, we create objects, we create collection, and then we count number of elements in this collection, instead of just asking database to retrieve number of books. And there are lots of methods like this which are useful when you can simply let database do the hard work and return results only. Actually, most of the time you should move as much work as possible down to database. Databases are faster than Ruby. Especially maybe after Ruby 3x3 it changed. No, it won't. So do yourself some favor, learn some SQL. It's great that beginners don't have to worry about SQL to get started. They really don't need it. But once you're no longer beginner, learn some SQL. And sometimes you want to have object loaded. Sometimes you will do something with that object later. And if you pass to other method, you don't want to pass object ID and in every method find this object from ID and ask database. But sometimes you just need ID. Especially when you're scheduling jobs, you should use object ID. Otherwise, you can easily bloat your memory. So think about memory and try to conserve it. It all boils down to fifth point, which is not understanding active record. At the beginning, I wrote using too much active record, but now I think it's not understanding. So we use it, that's okay, but we should know what we're doing. Oh, and remember about indexes. It goes without saying. This is a story from like 2007 or 2008. Anybody remember this? It's not Docker, it's Twitter. In 2008, Twitter was written in Rails, and it was failing so badly. This is fail whale, the screen people saw more often than tweets. And it all, it started this really harmful meme, Rails don't scale. Even there was this site, it's not there anymore, I checked it today. Who knew this site? Remember. So you typed into Google, can Rails scale? That was the first response in search engine. And you would see a page like this. Actually, it looked like this. And some tasks just take too much. And Twitter was doing a lot of heavy lifting on the front end. They weren't using any, maybe not any, but they weren't using enough background workers, background tasks. And sometimes you don't need to do everything during the request. The great example is sending mails. It may take 200, sometimes even 500 milliseconds to generate and send an email. And you can add mail generation to your controller after, so you created users and welcome email, or God forbid you can add it to callback in Rails model and let the user wait. But you can just enqueue job and forget about it. User will get her response quicker, web server will be blocked shorter, and you will be smarter. In Rails, it comes at almost zero cost with active job. So do yourself a favor and move hard work to the back. If users don't see it, and if users don't see you're doing something, they will perceive that your site is fast. It's so easy to forget about it, but move hard work to the back. There are plenty of examples of a code you can move to background jobs. For example, these are emails, push notifications, calculations, reports. You don't want to generate a report on request. Rankings, sometimes searches. You just have to ask yourself a question. Can I move it to the background job? My site will be faster. And you can start with active job, simply use sidekick, rescue. Maybe later you can use something more complicated. And it also will help you with scalability. So you will need less computing power for your servers on the front. And also if you get a lot of requests at once, and you can just enqueue them, and they will happen, maybe not on the same second, maybe after 1 minute, maybe after 5 minutes. Doesn't matter. It will happen, and you're not bounded to the power of your front-end servers. But there is one more thing. When you're scheduling jobs in Sidekick, don't use objects. Use IDs of these objects instead, unless you have plenty of memory and you know what you're doing. And this is the last story. And let's say you have done your homework. So you have measurement, you measure your responses, you measure your percentiles, you use cache, you were really smart and conservative about ACTIVERECORD and did a lot of things not included in the stock. And you have nice low mean responses times with double digits, and everything looks great. And then front-end developer, let's call him Kevin, puts rich single-page application in front of your backend. Damn it, Kevin. Backend matters, and it's important to have fast responses on the server. But it all can go to hell if you hide it behind slow, bloated front-end application. If your server response is 50 milliseconds, and then user will wait 4 seconds, user won't notice that you have responses counted in milliseconds. But they will notice that your site is slow. And what can you do about it? You can use turbolinks. You can use another new JavaScript framework. I don't know what they invented today. You can use Google Lighthouse to find bottlenecks and maybe even plug Lighthouse or tool like that to your continuous integration. But there is one proven method. It's a little ugly. The best thing you can do is to make crappy Android phone with limited bandwidth your test and demo device. And so give such phone to Kevin or to yourself, and Kevin, or you if you are writing front-end, will make your page quick and fast. I guarantee it. So don't forget about front-end, because front-end is what user sees. Thank you, and let your code stay fast.
Hello, thank you for sharing. I'm curious, what are the other 3 performance scenes you didn't add to your talk in the end?
Okay, I had 10 scenes at the beginning. Yes, you got me. One of them was big Ruby objects, but I kind of merged it into ACTIVERECORD. And right now I don't remember another 2. But 7, yes, 7 scenes sounds better than 10.
It's a play on the 7 capital scenes?
Yes, of course.
Yeah. Thank you.
That's all. Thank you, Aleksander.
Thank you.